Assalamu alaikum. My name is Ali Khan, room number 21 TE77, and our instructor is Dr. Jamil. And our today I will discuss the lab number 9 of this digital signal processing, and our title FIR filter using window method. So now we move to lab number 9 and task number 1 from example 7.4. So here is an example given that calculate filter coefficients of h of 0, h of minus 1, h of 1, and h of minus 2, h of 2, and h of minus 3, and h of 3. So plot the filter in time domain along with its magnitude response using these filters. So now we move to the source course code. Here in source code given filter coefficients and define plot filter in the time domain, and then calculate and plot magnitude response, then number of frequency points for plotting. So now we will run this source code. So here in the output we get filter impulse response, and also we get magnitude impulse of the filter. Now we move to the task one, part B of the task one. So here in part B, use windowing, Henning, and Blackman with the filter and observe their magnitude response. Discuss the window magnitude response. Note that use n is equal to 512. Now we move to the source code. Here we define given filter coefficient and then define length of the filter, which is n is equal to 512, and then apply window function and then calculate and plot magnitude response. So now we will run. So as I have run this source code, I have got one graph which is Blackman window and Henning window and Hamming window. So now we move toward task number 2 of this lab. And task 2, plot the signal in time and frequency domain in a log with its magnitude response, which sampling frequency and time domain, and x1 signal, x2 signal, and x3 signal, and after that x1 is equal to spread of these signals. So now we move toward the source code. So here in the source code, this is sampling frequency in this in time domain. This is signals of the difference, and here we plot signal in the time domain and then calculate and plot magnitude response, and then set the frequency axis limits for better visualization. So now we will run. So as I have run, this is signal in time domain and this is magnitude response of the signal. So now we move toward task number 3 of this lab. So in task 3, here is the application of FIR filters. First one is noise reduction, and the implement example in section 7.4. So for that we move toward the source code, and here is given that first we define given filter coefficients of these and then generate a noise input signal which sampling rate is equal to 8000 and time, and then original signal is this, and then noise signal which is this, and then apply a FIR filter to perform noise reduction, and then plot original signal, noise signal and filter signal, and figure subplot. We use subplot and then use plot for t and x, and then x label, and then use y label and then title. So same like that, and then we use to define apply the signal in original noise and filter. So now we will run this source code. So here we have three output, which the first one is original signal and the second one is noise signal and the third one is filter signal. And as we have had the noise, so the first was the original noise and the second was noise signal and the third was the filter noise signal. So all these are about the lab number 9. So thanks from watching.